20-25 years ago. It was a sand pit where they excavated sand to build to get building material, and when they finished that, they made this into a recreational area. And if you look at page number 7, for example, so this is what it looked like when still in use as a sand pit, and then it became a nature reserve or a recreational area. And if I look at page number 9, you see two photographs. The upper one is of 1993. I think that's already long way before you were born, I guess. Yeah, but still, that's why it's in black and white. You see here this gully, these two photographs. You see the second, you see the bottom photograph, you see this black triangle on top of the photograph. That's actually the forest over there. So, and then you can also see the gullies forming from 1993 to 1994. You see already a big gully appearing, especially the bottom. You see this dark line going from the tip of the black triangle downwards. So that's actually this gully. That has actually appeared within a couple of years. It grew up to this size. And the aim of today is that we're going to use some very simple tools to actually try to get a feel of how much sediment has been eroded down the hill. What's the volume? Because this gully used to be filled up to the soil surface with soil, but that soil is now down there somewhere. How much soil is that? So that's actually what we're going to try to measure. For that, we have an Excel form on Brightspace where you can fill in all the data that you're going to measure today. And that Excel form actually contains a model, a 3D model, which actually calculates the volume for you. And you are going to try to measure the input data for that model. So the model can do its work for the calculations. So if we continue to the page number 16, you see an example of how we're going to do that. We're going to actually we're going to measure cross sections. We're going to try to measure 3 to 4 cross sections each group. And what do I mean with a cross section? Cross section is something like this. If I consider this to be my first cross section, from the left bank to the right bank, I always in this field, this work, you always downhill is on the left side. So if you look downhill, left is left and right is right. So for example, if you are on a river bank, maybe you know the River Rhine. They also talk about the left bank and the right bank of the River Rhine, and that's left is when you look downstream. That's the consensus that everybody is using. So downstream, downhill is, and then that's the way you look, and then you see, left and right. So this is my first cross section. That will be my second cross section, and what we're going to try to measure. Maybe you can look here on page number 16. You see these vertical arrows. That's actually the surface area from the soil surface here. If you plot the line from the soil surface here to the soil surface here, and then what is the surface area of this cross section? That's what you're going to measure. So that's the light green arrows pointing downwards. So how we're going to do that? We have here this long tape measure, 50 meters in total. You attach it on the left side of the bank. You push it into the soil, and then you bring it to the other side. Then twist it once around. If you do the handle like this, then it will block, and then you can easily make sure it is straight, like this. On the left side on the soil surface, and same on the right side. And then I have this little tool. So this is a short tape measure, 5 meter tape measure, and we're going to measure what is the depth. If you read here the value 0, the depth is also 0. and if this line is nice and straight, and you see, for example, here at 25 centimeters the depth is 7, and then you see, have a look at, yeah, you see quite a straight line going up to here. There's not much happening. The slope is more or less the same. So this would be a nice third point to measure the depth. So at the length 69 centimeters, the depth is 30. And then here you see a transition. Here it gets a bit more steep. So that's another, you have to look at transitions, where the slope is getting from less steep to more steep. That's where you want to measure it. Because if you have a very simple shape, if this would be a perfect V shape, to actually get a good feel of what is the surface area of this V-shaped gully, and then you only have to measure the beginning, the middle, and the end. Then you have the perfect representation, and you can calculate what is my surface area. But the more irregular it is, the more measurements you have to do to get a good estimation of the depth. So you do that also all along this line, and you measure the distance and the depth using this. And then if you're gonna have a look at page number, what's the page number? Page number 20. You see here this table. It consists of 7 double columns. So for the first cross section, so that's actually this cross section, you can fill in the distance, starting there on the left side, 0, 0. The depth is 0, and then you fill in all these points that you're going to measure in these 2 columns for the first cross section, and then if you're going to do the second cross section, you use the second double column. So you're going to do that again, and because you know here the surface area, and you know the surface area over there, and if you multiply that with the length, the surface area here, the surface area there, you average the two. You multiply that by the length, then you get a rough estimate, or quite a good estimate, of the volume of this gully from the first section to the second cross section. So that's the way the model works. Another thing we need to figure out, because we want to build a 3D model, is if you have a look on the page before, page number 19, you see the other table, and for that we need to construct the 3D shape of this gully, and you see here several lines with distance, and then you always see distance from Li to Li plus 1. So if this is 1 and that is 2, so the upper line you see distance L1 to L2. So L is left, and this is right, and this is right. So you're going to measure the distance from left 1 to left 2. The same you do on the right side, from right 1 to right 2. And there's space for you to fill this in on the white lines for the distance. And then you also fill in the value from left to right for the first cross section. And then you can continue with the slope. To get a 3D model, you need to know the slope. And for that, we have this very nice instrument, the clinometer, we call it. It's a very nice instrument to measure the slope. And if you have a look at this table, we're going to need the slope in, as you can see, the unit is percentage. So with this one you can measure percentage or degrees, but in this case our model works with the percentage. So how does it work? You hold the string towards you, and you see the red dot, that's on the upwards, and the string is towards you. So red dot is upwards and the string is towards you. Then you have here this little glass that you can look through, and the trick is that you use both eyes. One eye to look into the glass. So maybe I can show you here. So I want to know what is the slope from there to there. So we have here these rods. Then you see here this transition from red to white. You also see that over there. So I want to know what is the slope from here to here. So I can do so by using this, looking with my left eye through the glass or into the glass, and keeping my right eye open, and then I see a horizontal line with my left eye, and I also see the scale inside this instrument. And then I point it towards the same transition from red to white on the opposite rod, and then I read the value. It says -12. So there's two scales. The right scale is percentage, the left scale is degrees, but we're going to use only the percentage scale, the right scale. So that's actually, because that is lower, that is indeed negative. So that is, if this would be upward, then it would be positive value, but this is minus because it's lower. And the trick is keep both eyes open. One eye look into the glass, and one eye, and then you can aim it to the opposite rod, and then you can read the value. And last but not least, to complete our 3D model, we're going to use a compass. Has anybody worked with a compass before? A very magnetic compass. It's very simple once you know how it works. I'll shortly explain it. So you pull the string towards you, you hold the string towards you, again same as with the clinometer, and then you aim the white dots on top of the instrument. You aim it where you want to measure, and then you see the red arrow is pointing north always, and you can turn this white dial so to the north. So you first you aim it, then you turn the white dial, so the end of this white dial is at the point of the red arrow, like this. So I turn the dial until the red arrow is at N. And then up here I can measure the value. As you know, degrees, it's a full circle, is 360 degrees. So 0 is north, east is 90, 180 degrees is south, 270 is west, and 360 or 0 is north again. So that's the full circle. And you read the value here, up here. So in this case it says 5.6. So if you multiply this value on this white ring by 10, you get the degrees of the circle. So this is 5.4, so this is 54 degrees. And again, you do that from right 1 to right 2, left 1 to left 2, and then from left to right. And then you have everything complete to fill the model, to make a 3D model of your gully.